All right, now we've got absolute value inequalities, which are going to be very similar to absolute value equations, but then a little bit different. With absolute value inequalities, you've still got the same scenario of looking at the distance from zero from the value, which means if I have x is greater than or equal to 7, this means two things. It means that my x is greater than or equal to 7, or it also means that my x would be less than or equal to -7. Remember, whenever we change the value by multiplying or dividing by a negative, the inequality symbol has to change as well. So in this case, when we think about the two values that are the same distance from zero, the -7 sign has been multiplied or divided by a negative, which means the symbol has to reverse with that number. So what would this look like graphed? Well, if x is greater than or equal to 7, that means it would be a closed circle at 7 going this way. For x to be less than -7, it would have to be a closed circle at -7 going this way. This should look really similar because it almost puts you in mind of our compound inequalities that looked like this, the ones that were the ors, where they were going in different directions. That's exactly what these look like. So the interval notation is going to be the one that has the union symbol, because it is going forever to negative infinity this way, and it's going to positive infinity this way. So that's going to be written with the parenthesis, negative infinity, comma, -7, because the circle is closed, we have a bracket, in union with another closed circle gives me a bracket, and this was +7, and it was going to positive infinity. For the other case, we have less than. So my x is going to be less than or equal to 4, but at the same time, my x will also be greater than or equal to -4. Notice I just simply took my sign, okay, and turned the symbol around because I made this +4 a -4. So when graphed, I will have a closed circle at 4, and since it's less than, it's going to be coming this way. Then I will have a closed circle at -4, but it says it's greater than, so I'm going to come this way. They will both join, they will meet together like my and inequalities when we did those. And the interval notation for those will be short because I'm going to have a bracket here at the -4 and another bracket here at the +4. So what does this look like? What does this all mean? Well, let's put it together. Your absolute value inequalities are just compound inequalities. Because just like compound inequalities, you have two graphs on the same number line. The way we solve these is the same as absolute value equations, with the difference being that we are going to switch the sign when we do our two cases for the negative. All right? So we need to first isolate our absolute value expression and make sure there's nothing on that same side of it. Doesn't matter if there's things inside of it, but whatever's on the side with that, we want to isolate. Then we solve both of our inequalities, we graph, and we do interval notation. All right, so I know I selected 3 and 4, but just to warm your feet up some, I want to look at number 1 as well. With number 1, you'll notice the absolute value expression is isolated. There is nothing outside of it like a multiplying it, or there's nothing underneath it that's like dividing it, so we can proceed. Set up your two cases. Your first case is going to be x plus 6 is greater than 7. My next case is going to be x plus 6, but since I am changing the sign of 7 to -7, my symbol has to turn around this way. Now I will simply solve each inequality. This inequality gives me x is greater than 1, and this inequality gives me x is less than -13. So I'm going to draw my line and put the -13 on this side and the 1 on this side. And my circles are going to both be open. At -13, it says it's less than, so that means it's going to have to go this way. At 1, it says it's greater than 1, so it's going to be open and it's going to go this way. You've got your solution and you've got your graph. Now let's write our interval notation, which will match our graph. From left to right, we know it's starting at -infinity, and we know it's ending at +infinity. So our interval notation is going to be parenthesis -infinity, comma -13, parenthesis because the circle is open, in union, and then another parenthesis because my circle is open, and then I've got 1 to +infinity. Number 3. Once more, I need to see if my bars are isolated. They are. So I'm going to set my two cases up. I first want to write -5 plus k over 3 is greater than or equal to 1. But then I'm going to come over here and I'm going to write -5 plus k over 3 is less than or equal to -1. Now all I have to do is solve each inequality. I'm going to do that by adding my 5 here. And then multiplying by the 3 to get rid of this fraction here. My k will be greater than or equal to 18 for this one. And on this side, I'm going to add my 5. And then I need to multiply by 3 here. My k will be less than or equal to 12. I've got my solutions. Now I need to graph them on the same number line. My lesser number 12 goes here. My greater number 18 goes here. Both of them will be closed circles. Closed at 12, and less than means it goes this way. And then closed at 18, greater than means it goes this way. And my interval notation will be -infinity, +infinity. Let's write it. Number 4. On number 4, once more we have our absolute value expression isolated, so we may proceed with our two cases. I've got 7 minus 4n is less than or equal to 27, and that's going to be 7 minus 4n is greater than or equal to -27. I'm going to solve by subtracting my 7. And then dividing by my -4. And when I divide by my -4, you got to remember to switch that inequality symbol right here and make it a greater than, okay? Because I divided by a negative number. This is going to give me a -5 right here. So there's one of my solutions. Subtract the 7 here. I've got -4n is greater than or equal to -34. And I'm going to divide by -4, which makes me flip my symbol again. And my n will be less than or equal to 17/2. And 17/2, if you write it as a decimal, I am okay with that. My graph will look like this. Put my smaller number on the left, my larger number on the right. And the line underneath tells me that both of them will be closed circles, okay? So closed circle here, closed circle here. Now, are they going to join or are they going to go apart? Well, if you look at the symbol here, it says that the n is greater than or equal to -5. Greater than means it's going to go this way. This says my n is less than or equal to the 17/2, which means it's going to go this way and they will join. That gives me, for my interval notation, a shortened bracket with the values -5, comma, 17/2 inside. All right, let's try a few more. For number 5, now we've gotten to a problem where our bars are not isolated. Let's do that. Let's isolate our bars, our expression, by multiplying both sides by 4. And now I will have q minus 1 is greater than or equal to 8. From here, I set up my two cases. Q minus 1 greater than or equal to 8. And then q minus 1 is going to be less than or equal to -8. Solve. And now I've got my number line. -7 here, 9 here. And at the 9, it's going to be closed and headed to the greater than direction. And at the 7, or the -7, it's also closed and it's headed to the lesser than direction. This gives me an interval notation of -infinity, comma, -7 bracket, in union with bracket 9, positive infinity. Number 7. My bars are not isolated, so I must do so. If you'll notice, this is being multiplied, so I need to divide by -10. When I divide by a negative number, y'all, I must flip my inequality symbol. So I'm going to have my bars 2r minus 1, and then I've turned it around to be greater than or equal to, and that's going to give me a positive 6. Here are my two cases. I have 2r minus 1 greater than or equal to 6, and 2r minus 1 less than or equal to -6. From here, I'm just going to solve again. So my r is greater than or equal to 7/2. And on this side, my r is less than or equal to -5/2. All right, now I'm going to graph these. -5/2 is going to go this side, and 7/2 is on this side. They are both closed circles. And my -5/2 is going to the lesser side. And my 7/2 is going to the greater side. -infinity, -5/2 bracket, bracket 7/2, +infinity. All right, let's just do one last problem, number 10. This is going to involve 2 steps before we can set up our cases. First thing we need to do is to get the -1 moved over here. So I'm going to say +1. That gives me -4. And bring down my expression that's in the bars. Bring down your symbol. And that's -20. From here, I have to divide by my -4. Dividing by a negative number flips this symbol. So I have x plus 9 is greater than or equal to 5. From here, I'm going to write my 2 cases. X plus 9 is greater than or equal to 5. And then x plus 9 is less than or equal to -5. Solve. X is going to be greater than or equal to -4. And it will be less than or equal to -14. Both of my circles are closed. And -4 is going this way. And -14 is going this way. That gives me my interval notation looking like this.